Okay, assalamu alaikum everyone. We are starting now. So today we need to start our next topic, which is coordinate geometry. Okay, so we are done with the 4 topics until now. Binomial expansion, quadratics, circular measure, and trigonometry. Binomial and circular measure were relatively smaller topics. Quadratics was relatively bigger, and trigonometry was quite big. It took us quite some time because there was a lot of detail in this topic. Now, today we are starting the next one, which is coordinate geometry. Okay. All right. So in coordinate geometry, there are actually a lot of concepts that you know about from O levels already. There are going to be a few new things, but most of the stuff you already know about from O levels. Okay. Apart from equation of circle, most of the other concepts are you're already familiar with, but still it's going to be important to remind ourselves about them. So we will quickly go through a number of concepts today that you know from O levels first, and then maybe towards the end of our today's class, we might do a couple of new things as well. But since all of these things can be tested, the ones that you know from O levels as well, we will need to revise them. So that's why I want to go through them quickly. Okay, let's start with this then. So first of all, there are some basics that you need to know about. What is coordinate geometry about? Coordinate geometry is basically about representing points, lines on these coordinate axes, X and Y axis. It's about representing points, lines, graphs on these axes, X and Y axes, okay? So first of all, you need to represent points on this X and on these X and Y coordinates, for instance. So if you have a point here where the on the X axis, you have a value of 7, and the Y axis, let's say you have a value of 3. What are the coordinates of this point? The coordinates of this point are 3 and 7. Okay. And if you have another point, so let's call this point A, for instance. Let's say you have another point, and that point is maybe here. Let's say this point has coordinates -5, and let's say this is +5. These are the coordinates of this point. Let's call this point B. It has -5 and 5. So these points A and B, they have coordinates 3, 7, and -5, 5. The first number that you have here represents the X coordinate. The second number represents the Y coordinate. The first number represents the X coordinate. The second number represents the Y coordinate. Now, first of all, you need to be able to find distances between these points, for instance. How do you find distance between 2 points? Let's start with that. Distance between 2 points. What's the formula that we have for that? You will need to remember this. It's not given in the formula sheet. It's x2 minus x1 whole squared plus y2 minus y1 whole squared. And then you take square root of that. Where does this formula come from? It comes from Pythagoras. How, if you have these 2 points, A and B, what you are interested in is the length of this line AB. Okay, length of this line AB. Now, if you were to make a right angle triangle like this, such that it looks like this, you have this vertical side, and you have this horizontal side, and you have a 90 degrees angle right here. We are basically looking for the length of this hypotenuse, right? That's what we're looking for. Now, can we represent these distances somehow in terms of X and Y coordinates? So in the first case, let's say the point A, it has coordinates x1 and y1. The point B has coordinates x2 and y2. What about this length? How will we find this length? We would say, okay, I'm sorry, I've done something wrong here. No one pointed that out. So the coordinates of this point are 7 and 3, not 3 and 7. I wrote them the other way around. The x coordinate is supposed to be 7 and the y coordinate is supposed to be 3. Sorry about that. Okay. How do you find this horizontal length for this? You would say subtract from 7 minus 5. Right? Because the x coordinate here is minus 5, here the x coordinate is 7. You'll do 7 minus 5. What does that become? You would say this is x2 minus x1. Now it could be done any way around, as in you could do x1 minus x2, or you could do x2 minus x1. Eventually you have to square that, so it doesn't make much difference. Let's say we do x2 minus x1. Minus 5 minus 7, that gives us minus 12. That's the length. It's a negative, but we have to square that. It doesn't really matter. That's one side. And then what about the other side? What about the height? This is 5, this is 3. What's the difference? The difference is 2. So in the formula, what we do is we take the difference of y2 and y1. So one side of this triangle is x2 minus x1. The other side is y2 minus y1. We have to find the hypotenuse. This hypotenuse. How can we find that? We can say 8 square, the hypotenuse square, is equal to x2 minus x1 whole squared, that's the base squared, plus perpendicular squared, which is y2 minus y1 whole squared. And then we take square root. That gives us the hypotenuse, and that gives us this formula that we have here. So this formula basically comes from Pythagoras like that. But now that you understand the background, what you still have to do is you have to memorize this formula. You will need to use this a lot of times in paper 1 and in paper 3 as well. So you need to remember this, okay? Remember the signs that you have here. Inside square, you have minus signs. A lot of people end up confusing the signs. Inside the square, you have minus sign. Outside the square, you have a plus sign here. Okay? That's what the distance formula looks like. So if you had to find distance AB now, how would that work? We'd say the distance AB, that is equal to, if we call this x1, y1, and we call this x2, y2, we can call any of them x1, y1, any of them x2, y2, it doesn't make any difference. x2 minus x1, what is that going to give me? Minus 5, minus 7, and then whole square of that, plus y2 is 5, y1 is 3, 5 minus 3 whole squared. What does that give us? Square root of minus 12 whole squared plus 2 squared. 144 plus 4, that's square root of 148. That's the distance. If you wanted to write it in exact form, you could just leave it like this. If you want to write it in decimals, it would be like this, 12 point something. Let me just evaluate that. Square root of 148. That gives me 12.17. Right? So that's the distance between the points A and B. Okay? That's how you find the length of this line AB, distance between the points A and B. So that's the first thing you need to know about. Then you need to be able to find midpoints of 2 points. Okay, so if you have 2 points, one point is A and the other point is B. If you want to find the midpoint of these 2 points, that might be somewhere around here. Right, this might be the midpoint. Let's call this point M. How do you find this midpoint? You have this formula for this. So we talked about the distance formula. Now we have another formula that's called the midpoint formula. Midpoint of 2 points, A and B. In this case, we have to find the midpoint of A and B. How would we do that? We would add both coordinates, x1 plus y2, x1 plus x2, and divide that by 2. And we would add the y coordinates, y1 plus y2, and divide that by 2. So basically the idea is, for finding the midpoint, we are just taking the average of these two numbers. So on the x-axis, this is minus 5, this is 7. Midpoint is going to be the average of these two numbers. So we just add the two numbers and divide that by 2. Similarly, vertically as well, you have 3 and 5. Midpoint is going to be in the middle. We take average of 3 and 5. We add the two numbers, divide that by 2. Right. So, and the midpoint formula basically comes from the idea of average. We're just taking average of the x coordinates and the average of the y coordinates. And that gives us x1 plus x2 over 2 and y1 plus y2 over 2. Okay. What do we get from this? X1 in this case was 7. X2 was minus 5. So we can say this becomes 7 plus minus 5. That's a 7 minus 5 divided by 2. And y coordinates, y1 is 7. Sorry, y1 is 3 and y2 is 5. So that's 3 plus 5 divided by 2. And that gives us 1 and 4. That's the midpoint. So the midpoint here that we marked, this point has coordinates 1 and 4. Okay, so that's the midpoint formula. You also need to remember this. Again, it's not given in the formula sheet. You will need to memorize this. Distance formula, x2 minus x1 whole squared plus y2 minus y1 whole squared, and then square root of that whole thing. Midpoint formula, x1 plus x2 over 2 and y1 plus y2 over 2. The idea here is we're just taking the average of the two coordinates. Okay, next thing, gradient. We need to be able to find gradients of lines. So gradient of the line AB. How would we do that? y2 minus y1 over x2 minus x1. So the idea of gradient is we want to find the change in y over the change in x. How much is the y coordinate changing for 1 unit change in the x coordinate? That's the idea of the gradient. How much is the y coordinate changing for 1 unit change in the x coordinate? You sometimes remember it like this as well, rise over run, as in how much are you rising, how much are you going vertically as compared to how much you're going horizontally. Let's find the value of this gradient first of all, and then we try to understand what that means. Y2 minus y1. Y2 is 5 and y1 is 3. So we say 5 minus 3. Again, it does not matter which one of the 2 points you call x1, y1, or which one you call x2, y2. You could also do the other way around. You could say this is x1, y1, and you could say this is x2, y2. It would not make any difference. Okay, so you can reverse this as well, and that's perfectly fine. In this case, I've called A x1, y1 and B x2, y2. I'm just using those points like this. 5 minus 3 divided by x2 minus x1. X2 is minus 5 and x1 is 7. So that gives me minus 5 minus 7. And that results in 2 over minus 12, which is minus 1 over 6. That's the gradient of the line AB. Now, what does this gradient mean? The interpretation of this gradient, the understanding of this gradient is, if x coordinate increases by 1 unit, or I can say when x coordinate increases by 1 unit, y coordinate decreases in this case, because we have a negative sign, by 1 over 6 unit. Okay, change in y over change in x. Or you can also say the y coordinate changes by, so we can generalize it like this, the y coordinate changes by minus 1 over 6 unit. So for 1 unit increase in x, what is the change in y? So when x coordinate increases by 1 unit, the y coordinate changes by minus 1 over 6. That means it decreases by 1 over 6. So on the graph, if you try to understand this now, if you go from minus 1 to minus 5 to minus 4, for instance, you're changing x by 1 unit. What happens to the y coordinate? It's 5 right now. It's going to reduce by 1/6. So the coordinate, the y coordinate at -4 is going to be 5 minus 1/6. So this minus 1/6, that will be 29/6. So you can check at when x equals -4, the y coordinate is going to be 29/6. So that's what the gradient means. That for 1 unit increase in x, how much is the y coordinate going to change? Is that okay? That's the idea of gradient. Now, what does gradient tell you? Gradient actually tells you the direction of the line. In which direction is the line going? So since it's negative, the graph looks like this. It's a downward sloping line. So negative gradient lines look like this. From left to right, they go down like this. Okay, in this direction. So let me actually write those different possibilities down here as well. So you could have different possibilities. You could have gradient that is positive. You could have gradient that is negative. When would the gradient be positive? When from going from left to right, the graph is going up. It would be like this, all of these different possibilities. As you go from left to right, the graph is going up. Okay, so this is one possibility. Similarly, negative gradient, that's if you are going down as you go from left to right. So when you go from left to right, the graph is going down like this. This is negative gradient because as x increases in this case, y is decreasing, y is going down. Okay, so that's why the gradient here is negative. So this is how the positive gradient and negative gradient lines look like. There are also other possibilities. You could have, for instance, a line that looks like this, a horizontal line. What's the gradient of this horizontal line? Horizontal lines have a gradient of 0. Why is that? Because the y is not even changing. For every 1 unit change in x, there's no change in y. So numerator is going to be 0. If you were to take 2 points here, let's say if this point was, let's just assume that this point is 2, 3. Then if you take another point where the x coordinate is, let's say, 6, what about the y coordinate? The y coordinate is still going to be the same because it's a horizontal line. It's the same horizontal level. So the y coordinate, if this y coordinate is 3, this y coordinate is also going to be 3. And if you find the gradient, then gradient is, by the way, also denoted by this letter m. So m represents gradient. So you can also use that. You can say m is going to be 3 minus 3. Now, no matter what you have in the denominator, you have 6 minus 2 in this case. 3 minus 3 over 6 minus 2, what does that give you? That gives you 0. So the gradient of this horizontal line is therefore 0. So horizontal lines have a gradient of 0. What about vertical lines? What's the gradient of vertical lines? Any idea? What's the gradient of vertical lines?
Sir, x-intercept is 0.
X-intercept is 0? We're talking about gradient, and it's not necessary that every vertical line has an x-intercept of 0. It could intersect at any point. Okay, so you're saying, so not the x-intercept. So basically what you mean is the change in x is 0, right? That's what you're saying. So that's not the right word that you used there. Intercept is something else. You mean to say that the change in x is going to be 0. Denominator is going to be 0. So what happens when denominator is 0? Let's take 2 points here, for instance. Let's say this point is 6 and 2. You have another point here. Now the x coordinate is going to be the same here. And the y coordinate could be, let's say, -4. How do you find the gradient? Change in y, whatever that is, 2 minus -4 in this case. Since the x coordinates are the same, the denominator here is going to turn out to be 0. So you have 6 over 0. Now anything over 0, what's that? Anything over 0 is undefined. So the gradients of vertical lines, they are undefined. You can sometimes call them infinity as well, and that at this level that is acceptable as well. Although it's more it's a more correct way of writing undefined. That makes more mathematical sense. But at this level, we can use both undefined and uh, infinity for this gradient, and that's going to be acceptable. Okay. All right. Now, another name that we use for gradient sometimes is also slope. So you should also be aware of that. It's also known as slope. And a notation that we use is for gradient is M. That's a notation that we use. Okay. So it can be called gradient or slope. Both of them work for this. Okay. So now that we understand what gradient represents, it represents the direction of the line, whether the y coordinate is increasing or decreasing with 1 unit change in x. Let's talk about two specific kinds of lines that you will be dealing with a lot here: parallel lines and perpendicular lines. So what happens when you have parallel lines? Now, how do you understand parallel lines? What do parallel lines mean? Parallel lines are basically two lines that have the same direction. They're going in the same direction like this, right? Parallel lines have the same direction. Let's say the gradient of one line is m1 and the gradient of the other line is m2. Since they have the same direction and gradient represents direction, their gradients are going to be equal. So if the gradient of one line is m1, the gradient of the other line is m2, then parallel lines are going to have the same gradient. Okay. All right. Then we have perpendicular lines. What happens in perpendicular lines? When we have two lines that are perpendicular to each other, they might look like this. There's one line here, there's another line here. There's a 90 degrees angle between these two lines. If we say the angle of one of these lines is m1 and the angle of the other line is m2, then how are these two gradients? Sorry, the gradient of one line is m1, the gradient of the other line is m2. How are these two gradients related? For perpendicular lines, we have this relationship that m1 multiplied by m2, that is equal to -1. That's how gradients of perpendicular lines are related. So the product of these gradients is equal to -1. If you rearrange this, you get m1 equals -1 over m2. And this is something that you can write in words as well. If two lines are perpendicular, what that means is the gradient of one is equal to the negative reciprocal of the gradient of the other. Or in short, you could also write it like this. In fact, their gradients, yeah. So you could write it briefly like this. Their gradients are negative reciprocals of each other. If two lines are perpendicular, their gradients are just negative reciprocals of each other. That's how you understand this statement in words. Okay. Now, if you have two lines, let's say we have line, or in fact, you have one line that has gradient m1 and you have another line that has gradient m2. If you know the gradient of one, can you write down the gradient of the other? You can do that pretty easily. If one line has gradient 5, what about the other one? Negative reciprocal. That means minus 1 over 5. If one line has gradient minus 3, the other is going to have 1 over 3. You have to take reciprocal and change the sign. Change sign, take reciprocal. Okay, you have to do both of those things. Achha. If you have something like this, for instance, minus 2 over 5, what would that become? That will become 5 over 2 for the other line, for the perpendicular line. Okay, similarly, if you had 1 over 3, that will become, in fact, we've used that before. Let's take 1 over 5 or 1 over 6, let's say. What is this going to become? It's going to be minus 6. Okay, so if you know the gradient of one line, the other's gradient is going to be negative reciprocal of the first one. Okay, so for perpendicular lines, the gradients are negative reciprocals like this. Any problem until this point? Any
Sir,
questions, anyone? Yes.
sir, in parallel lines, if one line is in negative quadrant and the other line is in positive quadrant, then what? Are they parallel? Are they, I mean, their gradient is same?
What's a negative quadrant and what's the positive quadrant? I don't understand that. So if you have these x and y
They are
axes,
in
what do you mean?
negative axis.
Which negative axis?
Or below x-axis.
X-axis. Below x-axis. Okay. How does the line look like below the x-axis?
Sir, like a horizontal line.
Okay. So we have this horizontal line. Then
Yes. And another line above x-axis. That is also
another line above
horizontal.
x-axis. It's also horizontal. Okay. Yes.
These two lines are parallel, so their gradient will also be same.
Yes. Both of them have zero gradient. Horizontal lines have zero gradient. So they're both the same. Yes.
Okay, sir.
They have the same direction, right? So they have the same gradient as well. And we talked about this before, that horizontal lines have a gradient of 0. So both of them have 0 gradient and they are parallel. Okay. All right. So that's what happens with the gradient. Now we need to understand how to write down equations of straight lines. Now here you might find something new, some of you at least, because there's one form that you've done in O-levels and there's another form that some of you have not done in O-levels. Equation of straight line. Let's talk about this. Straight lines equation. Now, what does the equation of a straight line look like? The standard form that most of you have done is this one: y equals mx plus c. Right? This is something that all of you, I'm sure, know about. This form is called gradient intercept form. What that means is, in order to write down the equation in this form, you need two things. You need the gradient of the line, and the second thing that you need is the intercept. That means the vertical intercept, the y-intercept of this line. If you have both of these things given, you can write down the equation. M represents the gradient, and C represents the y-intercept. Okay, y equals mx plus c. This is the equation of a straight line. M represents gradient and C represents the y-intercept. Now, if you were to write down an equation in this form, what does that really mean? What does that equation represent? Yes, you know how to write down an equation. For example, you could have an equation that looks like this: y equals minus 2x plus 5. Now, what does this really mean? If you were to draw the graph of this function, the graph of this line, the graph would look like this. The y-intercept is 5. So let's say this is 5. So the line is going to pass through 5. The gradient is negative, so it's going to be a downward sloping line, which might look like this. Okay. So we have this equation. Let's say this is what the graph of this line looks like. How is this equation related to this graph? How are these two things connected? Why do we say that this equation represents this graph, or this graph is the this line is the graph of this equation? How are the two things related? How are these two things related? What's the connection between the line and this equation? So the connection between these two things is that every single point on this line is going to satisfy this equation. Every single point on this line, it has to satisfy this equation. Satisfy this equation, what does that mean? That means if I had this point, for instance, let me mark one point here. Let's say this is a point. This point has coordinates 1 and let's say 2 and 1. I'm saying this point lies on the line. How can you prove that this point lies on the line? If you were to put this point in this equation, y equals 2x plus 5, y equals minus 2x plus 5. If you were to put that point in this equation would satisfy. Okay, so if you put 2 and 1, the left-hand side would be equal to the right-hand side. You would get 1 equals minus 2 into 2 plus 5. And that gives you 1 equals 1. That means this point lies on this equation. So number one, this this line basically means, this equation means that every single point on the line satisfies this equation. That's what this equation represents. That every single point in the line satisfies the equation. If you were to put that point in that equation, the left-hand side would be equal to the right-hand side. And the second thing is, you can look at it the other way around, that you can reach all points on this line using this equation. So if you input different values of x here, for example, if you put x equal to 1, that gives you y equal to 3. If you input x equals 0, that gives you y equals 5. If you input x equals 0.5, that gives you y equal to 4. If you input another value of x, that gives another value of y. So inputting different values of x gives you different values of y. All of those points are going to lie on this line. So 1 and 3, this point lies on the line. 0 and 5, this point lies on the line. 0.5 and 4, this point lies on the line. If you input different values of x in this equation, you'll get different values of y. And the points that you get, they're all going to be on this line. Okay, so that's the connection between this equation and the graph. Now, this is going to be relevant later on when we will be solving questions. You need to remember, whenever we know that a point lies on a line or any graph for that matter, that any function for that matter does not necessarily have to be linear. It could be quadratic, it could be a circle, it could be any other equation. That point has to satisfy the equation of that graph. Okay, that's the connection between these two things. If the point lies on the graph, it has to satisfy the equation. If you input that point in the equation, the left-hand side of the equation should be equal to the right-hand side. Okay. All right. So we know this this form y equals mx plus c. How can we write down equation of a line given some information? We would need these two things. We would need the gradient and the y-intercept. Now let's take an example. Let's say we had to find the equation of the line. Find the equation of a line that passes through, or let's say that has a gradient of -3 and that passes through, or let's do this first, and it has a y-intercept of 5, for instance. Okay, so we're given this information. Find the equation of a line that has a gradient of -3 and a y-intercept of 5. So we know the gradient, we know the y-intercept. We can use this form that we wrote above. That's y equals mx plus c. We can just input values in that form, and that will give us the equation of the line. So m equals -3. We can say this is -3 times x plus c. 5 is the value of c. That gives us 5 minus 3x plus 5. That's the equation of the line that we were looking for. Okay, pretty straightforward. You will just input the value of the gradient, which is m, and the y-intercept, which is c, in the standard form, and that will give you the equation of the line. Okay, that's very simple application of this form when you have the gradient and the y-intercept already given. Now, if you did not have the y-intercept given, instead you had another point given, what would you do in that case? For instance, you could have something like this. What if you had to find the equation of a line that has a gradient of, let's change this as well, that has a gradient of, let's say, 2, and that passes through the point -2 and 7. Or let's actually change this number so it doesn't confuse with this 2. Let's just use -3 and 7. Okay, find the equation of a line that has a gradient of 2 and that passes through the point -3 and 7. Now we have to find this equation. How do you do that? You know the standard form of the equation of a line, y equals mx plus c. This is something that all of you know. How would you do that? You already know the value of gradient. This is m. You can input that here. You'll say this is y equals 2x plus c. And now you have to find the value of c somehow. How would you do that? This is a point that lies on the line. The line passes through this particular point. Since the line passes through this point, it has to satisfy this equation. This point has to satisfy this equation. Now, since it satisfies this equation, we can just input that point here and use that to find the value of c. Okay, so we say, let's input -3 and 7 here. Why? Because this point lies on this line. It has to satisfy the equation. If we put -3 and 7, the left-hand side of this equation and the right-hand side of this equation, they should be equal to each other. So what do we get? We get 7 equal to 2 into -3 plus c. What value of c do we get from this? 7 plus 6, which is 13. So the equation of this line therefore becomes y equals 2x plus 13. In this form, we just input the value of c now. Y equals 2x plus 13. That's the equation of the line that we were looking for. Okay, so if we had the gradient given and a point given on the line, this is what we could do in this case. All right, now let's take another example. Let's say we did not have the gradient given either. What would we do in that case? Let's consider this now. We want to find the equation of a line that has a gradient or not. Let's do this instead. Equation of a line that passes through the points -4, -2, and let's say -2, -1, and 6. We want to find the equation of a line that passes through these 2 points, -4, 2, and -1 and 6. Now, what's the standard form of the equation of a line? Y equals mx plus c, right? Now, we do not know the gradient. We do not know the y-intercept. We don't have any of these two pieces of information. So what do we do first? We first find the gradient of this line. How do you do that? We have 2 points given. We can say this is x1, y1. We can say this is x2, y2. Let's apply the gradient formula. That's going to be y2 minus y1. That's 6 minus minus 2 divided by x2 minus x1. That's minus 1 minus x1, which is minus 4. That gives us 8 over minus 1 plus 4. That gives us 3. The gradient turns out to be 8 over 3. That's the gradient of this line. Now we need to find the value of c somehow. How do we do that? We put this value of gradient in this line, and that gives us y equal to 8 over 3x plus c. So now we have the gradient found, but we do not have the value of c yet, the y-intercept. How do you find the value of c? We know that this point and this point, both of these points lie on this line. Right? Both the line passes through both of these points. That means both of these points should satisfy this particular equation. So if we were to input any of those points here, the left-hand side would be equal to the right-hand side. So we can just input any one of these 2 points in this equation and find the value of c using that. Let's do that. Let's put any one of these 2 points. It doesn't matter which one you put. You could put minus 4, minus 2. You could input minus 4, minus 1, and 6. Both of them are going to work. Okay, both of them are going to work. Let's put, for instance, minus 1 and 6. What do you get from that? Put 6 in place of y. So you have 6 equal to 8 over 3 into minus 1 in place of x plus c. Let's see what the value of c turns out to be. C is going to be 6 plus 8 over 3, which gives us 26 over 3. Do not write these numbers in decimals. Leave them in fraction form. When we're writing equations, we need numbers in exact form. Do not use decimal here, because if you write decimal, that's not going to be exact because it's a recurring decimal. It's going to be 8.6666666 and so on. You can't write that in exact form. You will write it as a fraction, not as a decimal. Okay. So that's the value of c that we were looking for. We find the value of c as well. Now we can write down the equation. Now the equation turns out to be y equals 8 over 3x plus 26 over 3. And that gives us the final result. Okay. Any problem until this point? Any questions, anyone?
No, sir.
No? No problems? Okay, now this is one form of the equation of a line that you already know about. There's another form as well. And you will see that in A levels, we will mostly be using that other form because that's much quicker in most cases, especially when the y-intercept is not given. The other form is much quicker. When the y-intercept is given, this is fine. But when the y-intercept is not known, using that other form is going to be much more efficient in most cases. Let's understand what that form is about. That form is called gradient point form. Gradient point form. The earlier form was gradient intercept form. In that case, we needed the gradient of the line and the y-intercept, right? Now, we do not necessarily need the y-intercept. Any point would work. Any point in the line would work. Okay? It could be any point, not necessarily the y-intercept. The y-intercept would also work, but any other point would work as well. Okay? Let's try to quickly understand the background, then I'll tell you what the form is. So again, this is just for those of you who are interested. Let's say you have the gradient given, and you have a point given that lies on the line, point on the line. Let's call this point x1, y1. Okay, gradient is m. and the point that lies on the line, that is x1, y1. So let's say you have a point given and you have a gradient given. Okay. How would you find the equation of this line? How would you use it using this method that we've done before? Y equals mx plus c. What was the process? We would say, let's start from this. Let's start from y equals mx plus c. We first used to input the gradient here, right? Sorry, we would first input the gradient here like this, and then we would find the value of c somehow. Now in this case, gradient is m, so we just leave it as m. We need to find the value of c somehow. How did you use to find the value of c? Using the point that was given. So we know that this point lies on the line. We know that this point lies on the line. So we can just input this point in this equation, and that would satisfy this equation. Okay, let's put that here. So we say, let's input x1, y1 point in this equation. Just like we used to put this point before to find the value of c, like we did here. We said, let's put this point to find the value of c. Now we have generalized that, okay, if we have a point x1, y1, we just put that here. In place of x, we put x1. So it becomes, and in place of y, we input y1. So it becomes y1 equal to m into x1 plus c, right? x1 and y1 are the coordinates of this point, okay? And these are some numbers that we do not know at this point, but we're just calling them x1 and y1. This is the point that we know that lies on the line. So you can say, let's call this a known point on the line. This is a known point on the line, a point that you know about, okay? Now, what does that give you? y1 equals mx1 plus c. What's the value of c that you get from this? c equals y1 minus mx1, right? And then what did you use to do after that? You would put this value of c back in this equation. Let's do that here. c equals y1 minus mx1. Let's put that here. We get y equals mx plus, in place of c, you write y1 minus mx1. Now, if you just rearrange this, you get y minus y1 equals mx minus mx1. And if you take m common on the right side, you get y minus y1 equals m into x minus x1. And now what you can do is you can say, let's generalize this. Y minus y1 equals m into x minus x1. This is actually another form that we have for the equation of a straight line, that if we have the gradient known and a point given x1, y1, we can just input those values in this equation directly, and we would get the equation of, in this form directly, and we would get the equation of the line that we were looking for. So basically, we are skipping all of these steps, where we had to find the value of c. What we're doing here is we have put the value of c back in the equation like this and reached this form that we can now just remember and use directly. So in the previous question, for instance, these steps when we were trying to find the value of c, we can just bypass those steps and we can say, okay, after doing all of this, the form that you would get at the end would actually look like this: y minus y1 equals m into x minus x1. So we can just remember this form now. We can remember this form and we can say just put values in this form directly. Okay. Now, what do you need to be able to write equation in this form? You need two things. Number one, you need the gradient. And number two, you need a point, which is x1, y1. It's any known point on the line, any point for which you know the coordinates. This is the second form of the equation of the line. Y minus y1 equals m into x minus x1. Now you're going to remember this form. Okay. Now, how is this going to help? Let's revisit those problems that we saw above, that we solved above We find the equation of the lines using this form, y equals mx plus c. Let's see how we can find those same equations using this form now. So for instance, if we had to find the equation of a line that has a gradient of 2 and that passes through the point minus 3, 7, we say 2 is the gradient, m, and minus 3 is x1, 7 is y1. What's the standard form of the equation of a line that we've learned here? Y minus y1 equals m into x minus x1. All you have to do is write down this form, y minus y1 equals m into x minus x1. Just put those values inside this. Y minus y1, what is y1? Y1 is 7. Y1 is 7. Y1 is 7. And the gradient is 2. X1 is minus 3. So we have x minus minus 3. And this is going to become y minus 7 equals 2 into x plus 3. What you can do is you can actually just leave your equation in this form, and that will be the equation of the line. You would not even need to simplify this in most cases. This is also a standard form of the equation of a line. So it's perfectly acceptable to leave it in this form. Unless when sometimes they ask you to write down the final answer in a particular form, then you have to convert your answer to that form. But if they don't specify any particular form, you can just leave it like this, and this is going to be acceptable. If you wanted to convert it to the other form, y equals mx plus c, we'll just simplify this. You'll say this is y minus 7 equals 2x plus 6, take 7 to the other side, and that gives you y equals 2x plus 7, 2x plus 13. And that's also okay. That's exactly the equation that you got before. Y equals 2x plus 13. Okay. So now you can use this form, y minus y1 equals m into x minus x1, to do such problems directly where you have the gradient and a point given. Let's do one last example. We also did this above, where we had 2 points given. And we use those 2 points to find the equation of the line. Let's see what we get from this now. We need to find the equation of a line that passes through the points minus 4, minus 2, and minus 1, 6. What's the standard form of the equation of a line that we have learned? The gradient point form, y minus y1 equals m into x minus x1. Now, gradient is also needed for this form. So you do need to find the gradient. We can call this x1, y1. We can call this x2, y2. Then the gradient is going to be 6 minus minus 2, that's 6 plus 2. Let's write it like this, 6 minus minus 2 divided by minus 1 minus minus 4. And that will turn out to be 8 over 3. That's the gradient. And then in place of x1, y1, you can input any one of these 2 points. You can input this or this. It doesn't matter. Any one of those two. Okay, you can call any one of them x1, y1. It's not necessary that you have called this x1, y1 for finding the gradient. So you would need to put that point here as well. You can input any of those points. It doesn't matter. Okay, let's do that now. So let's say now we input in this equation, we say let's input m equal to 8 over 3. And in place of x1, y1, let's input minus 4 and minus 2, this point, the first one. And you will get the equation of the line from that. Y minus y1. What's y1? Y1 is minus 2. That equals m, which is 8 over 3, into x minus x1. What's x1? x1 is minus 4. X minus minus 4. Okay. And that becomes y plus 2 equals 8 over 3 into x plus 4. And again, as I said, you could just leave it like this as well. Unless the question asks you to convert it to a specific form. If it doesn't, you can leave it like this. If you wanted to convert it to the other form, you could do something like this. You could say this is y equals 8 over 3 times x plus 8 times 4 is 32. That's 32 over 3. And then this 2 goes to the other side and gets subtracted. Now you simplify this on your calculator, you have y equals 8x over 3 plus 32 over 3 minus 2, that's going to give you 26 over 3. And that's the equation that you got above as well. 8 over 3x plus 26 over 3. And that's the form that we're getting here as well. So this is another way of writing down the equation of a straight line. So now you have two forms. You have two forms. One form is y equals mx plus c, and the other form is y minus y1 equals m into x minus x1. You can use both of these forms for every kind of problem when you have to find a straight line, equation of a straight line. Both of them will work in every case. Okay, both of them will work. However, the first one is going to be more efficient when the y-intercept is known. In that case, the first one is going to be more efficient. And in every other case, the second one is going to be more efficient. You use this when the y-intercept is not known. And that is going to be the more common case as well when you do not know the y-intercept. Okay, and in that case, you would be using this form y minus y1 equals m into x minus x1. And this is going to make your working a lot quicker as well. So I would highly recommend that you remember both of these forms. We will be using this one in most of the problems that we do from now on in coordinate geometry and later on in differentiation, in functions. You will see this being used a lot. Okay, any questions? Any questions on this? Any problems, anyone?
So, sir, we could use both forms to find the same thing.
Yes, you can use any of these two forms to find the equation of a line. The first one is more efficient when the y-intercept is known. The second one is more efficient when the y-intercept is not known. Okay. And in most of the problems that we will be dealing with, the y-intercept would not be known. So we would often prefer using this form because it's going to give us the result quicker as compared to y equals mx plus c. Okay.
Okay, sir, thank you.
Any other problems, anyone? Any other questions? All right, good. So that's it for today then. Tomorrow we will learn how to solve simultaneous equations. Again, you know that already. I'll just quickly review that for you. Yeah, so that's one thing. Solving simultaneous equations. And then we will learn how to find gradient of a line from its equation. That's also a very simple thing. And then we'll talk about diagonals of quadrilaterals, equation of perpendicular bisector, and then these areas. Yeah, so it's going to take some time. It's also a relatively long topic, although it's not very difficult. But yeah, so in the next class, we'll also be doing some more concepts. What I'll do in the meantime is I'll be uploading a worksheet. And since you already know most of these concepts, I would recommend you to start working on that worksheet already. So we will be looking at some questions from the worksheet in the next class, hopefully as well. In addition to doing some concepts. So for that, I would recommend that you start working on the worksheet already. So in case you have any problems, then we can discuss them. And keep in mind that we might have an extra class this week. It's not confirmed, but we will have a class on Thursday, but we might have another one on either Friday or Saturday, but I will confirm if I do schedule that. Okay. And next week, we are most likely we most likely are going to have extra classes, maybe 2 extra classes, because then we have Ramadan starting the week after that. So we would want to get a slight heads up during the next week so that we don't have to do many extra classes during Ramadan. Okay, so that's it for today then. I'll see you again tomorrow. In fact, Thursday. Allah Hafiz.
Allah Hafiz, sir.
Allah Hafiz.